A capacitor with capacitance of 2.12 farad is charged to a potential of 1.69 volt and then discharged through a resistor. When it's discharged by half of its initial charge, so I would say that its Q final is equal to the Q initial divided by 2. How much energy is delivered to a resistor? So you have to find delta U. Now the delta U is equal to the U initial minus U final. Now first of all, let's find out what was the initial charge. Now Q initial charge is equal C times V initial, right? So if you plug the numbers, 2.12 multiplied 1.69, then you should get that Q initial will be equal to the 3.58 coulombs. Okay. Now we also know that Q final is a half of the Q initial, which is 3.58 divided by 2, which will give you 1.79. Okay, now we found what is initial charge and what is the final charge. So let me just highlight it. Now, how can we find the U initial? U initial is basically, you can have a couple of formulas. So the easy way is just to use CV, okay, which is 1 over 2 CV squared. Now, if you plug the numbers, where you have 1 over 2 multiplied C is 2.12 multiplied 1.69 squared, and if you do calculation, you should get that is equal to the 3.027 joules. Okay, now let's find our U final. Since we found the final charge, then also the capacitance is a constant, so we don't need to use V initial because it's completely different. We don't have V final, so therefore we can use C and the charge to find the final potential energy. Okay, so for that reason we have a formula is basically 1 over 2 and the Q final divided by the C. Now C is constant basically, which is 1 over 2. Q final was 1. By the way, it's squared 1. Q final is 1.79 squared. C is 2.12. So then if you do calculation, you should find that it's equal to the 0.755 joules. Okay, now finally you just have to find the difference between those things, which is delta U is equal to U initial minus U final. Now U initial was 3.027 minus 0.755. So if you subtract them, you should get 2.27 joules. Now this is your final answer. That's it.